Good morning, Morgan, and good morning to any of your friends out there that have joined us for this video today. And today we're talking about floating point math, which is it's just decimal pointy type stuff. Okay, and you should pretty much already know about this stuff. But we're just going to go and do some examples that just shows you like, oh, what happens if you round stuff before you add them, stuff like that. With that said, let's get through this reading.
Decimal floating point arithmetic. The decimal module offers a decimal data type for decimal floating point arithmetic. Compared to the built-in float implementation of binary floating point, the class is especially helpful for financial applications and other uses which require exact decimal representation. Control over precision. Control over rounding to meet legal or regulatory requirements. Tracking of significant decimal places, or applications where the user expects the results to match calculations done by hand. For example, calculating a 5% tax on a 70-cent phone charge gives different results in decimal floating point and binary floating point. The difference becomes significant if the results are rounded to the nearest cent.
Okay, all right. Now, this sounds boring, okay, but I want to tell you a story. Okay, watch the movie Office Space. In the movie Office Space, they have an idea to steal money from their company by rounding everything down and taking all the little bits of the cents and summing them up, and then that comes to real money, right? And what's interesting is somebody actually did that at a bank somewhere, I think in Richmond, Virginia, and they were bringing in like $1,500 a month extra on in like a little, they had to go into like a weird little bank account, and they would draw the money out with an ATM card, and they thought they were slick, but they weren't slick enough. They got caught. I won't bore you with the details, but it was a good idea until somebody figured out what's going on. So anyway, that example will give you an idea on how important rounding is. Okay, let's keep going.
The decimal result keeps a trailing zero, automatically inferring 4-place significance from multiplicands with 2-place significance. Decimal reproduces mathematics as done by hand and avoids issues that can arise when binary floating point cannot exactly represent decimal quantities. Exact representation enables the decimal class to perform modulo calculations and equality tests that are unsuitable for binary floating point.
Blah, blah, blah. You should have learned all this in math class by now. With that said, let's go over and take a look at the sample code. And here's the sample code. I changed it around a little bit. I don't think here. Okay, all this does is this example is like going, hey man, this is what happens when you round it before you do the math, and this is what happens if you round it after you do the math. Okay, so anyway, and of course the difference is going to be 1 penny. That's what you want to do. If you could just take that penny and put it aside, and then every time you make this rounding, you get another penny. Okay, so this one was like the modulus. Okay, so the modulus, what's the modulus? It's the remainder of you divide something. So if you do 10 and you divide it by 3, you have 1 left over. But that's 0 when this is like 10 divided by 1. There's nothing left over. So I made a division because, why not? And freaking 0.00 is boring, so I changed that to... Anyway, that said, let's go run the code, and let's take a look at the output, and we'll talk about it some more over there. So we hit the magic button, chugga, 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 boom! Now it's time to go look at the output. See you over there. And here we are in the output. Okay. See, you round it here inside, and it's 74. You round it out here, it's 73. All right. You take that penny and you hide it in an account somewhere. Da, da, da. Anyway, and then we've got the, divide 1 by 1/10, you get 10. You know, I don't even know what this one's for. The sum, oh yeah, that's true. No, something false. These return binary, you know, on or off, true or false. Okay. And with that, the video's over. Only 2 more videos to go, and we're done with this series, and then we can go do something a little more interesting. And with that, go out, have some fun, don't get into too much trouble, and we'll see you in the next video.